Hello students, welcome to Unit 4 Notes, Section 4.2. I did part of the warm-up because I really felt like I had to explain this one, so please watch this video, or you can pause it and try it on your own, but definitely watch the rest of this. So in number 1, it says, what can you conclude from each diagram? I put that AB is congruent to DE because they are congruent, they have congruent tick marks, along with angle C being congruent to angle F. In this next one, I have a little bit more information. I have S is congruent to Q. I also have that SRP. Notice I'm starting at S, going to R, going to P. I'm starting at the 1 tick mark, so 1, 2, 0. I'm going to follow that around as well, 1, 2, 0. So 1, 2, 0, 1, 2, 0. So SRP is congruent to, well, in this case, QPR is congruent to SRP. And now the last one is this shared side here, this shared side that they both share. So PR and RP are congruent. Again, just going in order. So again, PR is congruent to RP. So PR of this triangle, of the left triangle, PR is congruent to RP of the right triangle. All right, this next one, here we have angle M and angle S are given. They're congruent. So that's pretty easy. The next one is I have these parallel lines here. I have a parallel line, a parallel line. It kind of looks like it's cut by a, looks like it's cut by a transversal. Therefore, the alternate interior angles are congruent. So I know I'm drawing over the diagram and making it a little bit more complicated, but if we follow this path down, we have parallel line, alternate interior with our parallel line. We have two alternate interior angles, therefore they are congruent. Okay? And so I wrote that MON is congruent to, in order, SVT. This last claim I'm going to make is that TV is congruent to NO. And here's how I'm going to make that claim. So let me, in a different color, represent TV and then NO, that those pieces are congruent. How do I know that those pieces are congruent? Well, I'm going to do a couple things. I'm going to kind of do a little bit of a proof here. So TO and OV, if I were to add TO plus OV, I get what's called TV, right? This is the segment addition postulate. So TO plus OV equals TV. And then working this way, NV plus VO is NO. I'm just adding them together and getting this. Okay, so those are basic statements. What's another statement I can make? I can say that TO is congruent to NV because they have tick marks. They actually have physical tick marks. So I'm going to say that that TO is equal to NV because of the tick marks. So if I were to add, watch this, if I add OV to both sides, because for both of these, I can add VO or OV, which is this middle section right here. They're both the same section. OV and VO are the same exact thing. But let me add them to both sides. That would give me TO plus OV on the left-hand side. And on the right-hand side, it would have NV plus VO. Well, what do I know about TO plus OV? TO plus OV is TV. So I could substitute in TV wherever I see that piece. And then what do I know about NV plus VO? I can substitute in NO. So I'm just using my segment addition postulate. So I get TV is equal to NO. Therefore, TV has to be, if it's equal to it, TV has to be, TV has to be congruent to NO. And there we are. And that's where I got that statement from. So you don't have to write all this down, but you just have to know that the overlapping parts can be added to TO. The overlapping part OV can be added to TO and NV, and it will then extend the congruence from T to V, and then from N to O. So that right there is the warm-up. Now, why do I bring this up? Well, listen, Back in our last lesson, you saw that for triangles to be congruent, we needed 6 congruent parts. We needed all the sides to be congruent. So 3 was congruent to 3, 4 was congruent to 4, tick mark was congruent to tick mark. And then we needed 3 angles. A and E were congruent, sorry, 3 pairs. A and E, B and D, this C and this C. So the question now for this lesson is, do I need all 6 pieces? Do I need all 6 pieces? The answer is no, but you need at least 3, and they need to be in the right order. So you need 3, and they need to be in the right order. So section 4.2, and then 2 more sections we do, we'll talk about what order matters and what we're able to focus in on. So this one is this one is not enough. This one, okay, let's just get into the lesson. What orders are we going to look at today? We're going to look at side. This stands for side, side, side. And this stands for side, angle, side. These are the orders we need and the specific pieces of information we're going to look for. So, in a side, side, side triangle, if I have a triangle that has sides 3, 4, and 5, and I have another triangle that has sides 3, 4, and 5, the conclusion you can make is that not only are the sides congruent, but all of their angles are congruent as well. That means that these are congruent, these 2 triangles are congruent by literally side, side, side. And then here's my other one. Here's another one. Let's say I have a side that's 3 and a side that's 4, another side that's 3 and a side that's 4, and the angle between the 2 sides, this angle right here is what we call included, which means stuck in between. It actually makes up the sides, okay? That angle, let's say that angle had the measure of the angle equaled 62 degrees, and the measure of this angle equaled 62 degrees. Well, guess what? This is also a congruent triangle with that included side angle in between the sides. And that's what our lesson's about today. Just the side, 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 and the side angle side postulate. So here's what it looks like. Do I need all 6 pieces of information? No. As long as I have 3 pairs of, so I can, what does it say? You learned that you need 3 pairs and 3 pairs. Yep, we don't need 3 pairs. Here is an example of side, side, side. As long as the 3 sides are congruent to the other 3 sides, we have 2 congruent triangles. Awesome. And then what else do we notice? We see that by side, angle, side, we actually also have enough information. Don't forget, that's your included angle. Why is it included? It's stuck between the 2 sides. So look at this, side, angle, side. And I'll highlight those sides now. So here's your side, here's your side, here's your included angle, and then here's your side, here's your other side, and here's your side and side with the angle stuck in between. If this is the order that both triangles have, then you can conclude by side, angle, side that, that these 2 triangles are congruent. Okay, so the word included means it's used frequently when we're talking about referencing the angles and the sides of a triangle. So we could have an included angle here, like angle N, that's stuck between side NX and NB, or we could have a side that's included between 2 angles. So for instance, angle X and angle B, the side in between is XB. So you notice that they repeat the same letters for the word inclusion. So Side BX is included between sides B and between angles B and X. And N is included between sides NB and NX. Look at this. B and X is included between BX, and NB and NX are included between N is included between NB and NX, so angle N. All right, that is what included means. So the next questions are just going to ask us about different questions. Are they congruent, or what other information do we need to make sure that they would be congruent? So this first one says that RS is congruent to TK. So RS is congruent to TK, and that's already marked for us. And then it says, what other information do we need to know? What other information do you need to prove that RSK is congruent to TKS by side angle side? Well, here's the important part. Look at what's repeated, SK and KS. We know that SK is congruent to KS because they are a shared side. So this is not information we need. The reason why it's not info that we need, because it's already been stated. So I'm sorry, we need the information, but we have the information, so it's not something we need. This is asking for other information besides that. So this assumption we can make because they share that common side. So now we're going to look, how can they be congruent by side angle side? Well, here I see a side, and I see an angle, and I see a side, and I see an angle, and I see a side, and I see an angle. I have all this information, but how by side angle side would that be congruent? So let's take a look at the sides that are marked. So here's marking 1, and here's marking 2. If I were to ask you what angle those two sides have in common, your response should be that they both have angle S in common. So RSK is the angle that we're talking about. And then let's take a look at this triangle over here. And this has, look at, side and side, making this the angle that we're looking for. So what we need to know, and we don't know this, so let me erase what I did. I don't know it, right? What I need to know is this angle congruent to this angle? So I need to know, does the measure of angle RST equal the measure of angle TKS? So again, RST, I'm going down the 1 tick mark, down the 1, down the 2, down the 1, down the 2. Does angle RSK equal, or is it congruent to angle TKS? That is the information I need to know. So I am going to just leave that. That is my answer. I need to know this information to prove it by side angle side. I don't know if it's true. Oh, wait. So what I need to say is RST congruent? I should be using congruent to angle TKS. That is what I truly need to know. Are those congruent? And what I'll like to do is I'll put a little question mark, because that's the question that's being asked. Do I know if they are congruent or not? Or what other piece of information do I need? I need that piece. I cannot say that they're congruent without that piece. So now, what about the next one? By side angle side. Well, let's see. You know what? They both have side 6. They both have side 7. This side 8, I can kind of just ignore it. I don't really need that at all, because I'm already looking at 2 pairs of sides. because they don't want it by the side, they want it by the side angle side. So side angle side, I have my one pair, which is the 7s. I have this second pair, that's the 6s, okay? And now I'm going to take a look at, okay, what do they have in common? So they have this side in common. They both have this side in common. So now when you go to look at your angles, you go, well, what angles between both of these? It's this angle here and this angle here. Those are the included angles. So I need to know, is this angle and this angle congruent? So I need to know, is angle BAC congruent to angle BAC? And I want to do it in the right order, so I'm going to say DCA. Are they congruent? That's the information I need to know. Again, if it was asking side, 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 the answer would be different. If it was asking side, 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 it would be asking me, do you, I would need to know that BC was 8, right? That would be by side, 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 but that's not how it asked me. So this 8 is kind of, we can kind of ignore it for right now. We don't really need to work with that. Okay? So if it was by side, 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 the answer would have been we needed to know BC was 8, because then we would have all the sides, we'd have all the info that we need to prove them congruent. What additional information do you need to prove the two triangles congruent by side angle side? Well, here, is that really by side angle side? Yeah, side angle side. So let's take a look. Well, they both share this side right here. And this can be one of two things, okay? We can look at it this way. We could say, well, they both have that side and they both have that angle, so all we need is these sides. So I need to know, because you have that tick mark, you have this tick mark. So I would either need to know that WV, I would need to know, is WV congruent to WZ? I need to know that. Or, let me use a different color. Or I need to know that, look at this side, look at this one. I could do this direction as well. I could maybe say, well, I know that this is congruent to this. So these are my two sides, so that's my sides. And then I'll also use this side as an option. Let me see if I can change these styles. Kind of want both to show up here, if you get what I'm saying. Because it depends on what direction we're looking at it in. You know what? Let me do a little bit thicker of a line. Whoops. That might work a little bit better. Whoops. Because I'm double using this, so I kind of want both styles here. There we go. That looks pretty good. So if I'm going in the other direction, I know that those sides are congruent. So I might need to just know that does angle, I'm running out of room here. So, or angle YVW, is that congruent to angle ZVW? So I need to know either one of these items. Okay, this does look like a multiple choice question. So truly, I have two options here, but let's see what options I'm given as a multiple choice question. So it says, what additional information? So I have WV. I don't see WV at all. YW and ZW. Oh, you know what? Did I mess this up? I messed this up. Okay, this should have been, why did I say WV and WZ? I meant WY and WV. Here's WY, I meant this side, and then WZ is this other side. My apologies. Okay, so that's one of them. I see WZ, I see WY. I don't really see angle Y or Z, that's not an option. WVY and ZWV. ZWV is the wrong one. WVY is the right one. But so I'm not looking for this one, and no additional information needed. So based on the multiple choice question they gave me, the answer is going to be the first statement that I made earlier. Okay. Yeah, WY and Z, WY and WZ. Okay. That one's a little tricky. I had two options. All right, are the triangles congruent? So are they congruent? Well, take a look. Are they congruent? I have some side angle side happening here. I see a side, and I see a side. I see an angle caught in between, so it's looking pretty good. So that looks like side angle side. Okay. And then I'm looking over here. Ooh, look, I see two sides and an angle. But hold on. Does this match? There's your sides. And now your angle's way over here. That one is a side angle option. No. So the answer to this is no, we don't have enough information. Or we could even say this information is out of order. In triangle CAT, Because in theory, if angle R is the angle that has a tick mark, then angle C should also be the one with a tick mark, says this statement. And R and C don't have those tick marks. Therefore, as the included angle, we don't know about them. Okay, we can't prove it, and that's what the question's asking. It doesn't say RED is congruent to CAT. It says, can you prove that it is? All right. From the information, can we prove that AEB is congruent to DBC? And let's see. It looks like I have this side and this side. It looks like I have this side and this side. And it's looking promising for this angle because that angle does look like it's included, but this one does not look like it's included. This looks like an side angle option, and this one looks like a side angle side option. So again, this is not enough information. I can just copy and paste the statement right here. The information's out of order in my AEB triangle. My first one on the left. And again, it's just that order you have to look for. DBC, the right triangle, was fine. It's the left triangle that has the angle that's not included. And I'll point right to it. Angle not included between the sides in question with the tick marks. Okay? All right, so here we have homework exercises, notes for 4-2, and I'm just going to finish these up quickly. Is the information you are given enough for you to prove that the two triangles are congruent? Explain. And so I'm going to throw in some tick marks here for my vertical angles. It appears that this is side-side angle, and this is side-side angle, and so the answer to this is no, not enough information. Side-side angle is not one of my postulates, so it could possibly be, but at the moment we don't know if there's enough information. Okay, here we're going to throw some tick marks in on the shared side, and this looks like side angle side and side angle side, and it's looking as if that works. That works pretty well. So it is yes by side angle side postulate. I just want to make sure I answered all the question, the entire question. Do you have enough to prove? Yes. Okay. What other information would you need to prove the two triangles congruent by side, 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 or side angle side? Well, let's go with side angle side for this one, right? So we're going to do side angle side for this one. What other info would I need? I would need to know that GL was congruent to NM in that order. That is what I would need to know. That's the additional information because we have two of the three parts. Okay, this next one. What about by side, side, side? Okay, I don't really know if this question's asking for both, but we can do both. We might as well. What about by side, side, side? Well, I would need, literally, I would need this part. You know what? I don't think it's asking that, but I would need this part. And I would also need, by side, 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 I would need that part. And I would also need to know that NQ, well, let me go to this, that GT, is congruent to NQ. That's by side, side, side. For this one, by side, 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 I would only need to know that RS was congruent to, let me see, RS would be congruent to, I have to go in the correct order, so that's going to be WU, because I'm going from the 1 tick mark to the 0, so I have to go from the 1 to the 0. So that would be by side, side, side. I would need to know that, which I don't know. By side angle side, it appears that I was given a side and an angle. I just need that last side. So you know what? This is exactly the same statement, to be honest with you. So by either one of these, I would need that same piece of information because of the placement of that angle. Okay, so those are the answers for 8 and 9. Number 10, copy the triangle, start any vertex, and label. So I already copied it for you. I'm just going to label it WVU. It doesn't matter where we put them. What sides include V? Well, angle V is included between side WV and VU. Okay, so WV and WV and UV, right? So the two sides that make up V, angle V, are WV and UV. Of course, the letter V is in it, in both of them. What angle is included between WV and WU? Well, they both have W in common, so the angle is angle W. We can check it, so angle W. If we have WV and WU, there's WU, there's WV, there's WV. So this angle right here is angle W. Okay. What angle includes UV? What angles? So this one is going to be angle U and angle V. Angle U and angle V, because UV is made up of both angle U and angle V, right? UV is made up of angle V and angle U. What side is included between W and U? Side WU. All right, sorry about that. So what side is included between WU? It's angle W and angle U. It's WU. Name the indicated parts of triangle XYZ without drawing XYZ. So what angle is included between XY and XZ? Well, that XY and XZ, X and X. So angle X is the angle included between them. And the sides that include Z is going to be side XZ and side YZ. All right. Is there enough, I think this is we're almost done. Is there enough information to prove the two triangles congruent? If so, write the statement, the congruent statement, and name the postulate you would use. If not, write not possible and tell what other information you would need. This is very comprehensive. So let's see, I used purple. All right, it looks like side angle side for this one, side angle side for this one. Okay, so side angle side postulate or theorem. So that works. And this one is going to be triangle ANG is congruent to triangle RWT. Again, there's like a whole bunch of answers for this one for how to name the triangle. Just make sure you go in order if you got something different. The next one, ooh, this is a side, side, side all day. Side, side, side postulate. So here we have triangle KLJ is congruent to triangle MON. All right. Next one. Okay, so this one is not congruent because we don't have three pieces, but we could do anything. We could do side angle side. Let's do by side angle side. To do side angle side, I would need, so the answer is no, not congruent. So the answer is no, not congruent. By side angle side, we would need to know that angle H is congruent to angle P. And that's it for that one. And our next one, let me just do the box. Okay, next one, we have, ooh, we're good, side, side, side. So that's okay that this has one tick mark, one tick mark, one tick mark, one tick mark. That's fine. They're just isosceles triangles. Those are all congruent. And then we have these last ones. So we're going to say yes by, let's see, yes by side, side, side. Postulate. And this has a few different answers we could answer with. But I'm going to just say triangle EJF is congruent to triangle, and I could say FSV or VSF. It doesn't matter. Let's get crazy. Let's say VSF. That's just one of the answers. You can flip those because you have an isosceles triangle. Gives you multiple options of writing that triangle congruent statement. Order can be manipulated for that one. All right, this one we have this and this. We have this. We have this and this because they share that side. So yes by side, side, side. And so I'm going to say triangle TRB is congruent to triangle SRB. And there we go. Okay, the last one. Ooh, yes. This is by side angle side. Yes, by side angle side because of the included angle. So triangle, let's do PQR. So I'm going 2, 1, 1 down the right angle is congruent to triangle NMO. And that looks pretty good. Okay, and that's it for that. So all you have now is the 4-2 work to do in class along with the IXLs. Good luck. Hello students, welcome to Unit 4 Notes, Section 4.3. This is a continuation of our pretty long lesson. That's pretty much 2 lessons, but here we are. I did the warm-up, so you can pause this right now and try it out, but I will go over it very quickly. So we'll continue on with our lesson now. So JH, which side is included between the given pair of angles? Well, if the angle is angle J and the angle is angle H, then JH is the item caught between them. That's side JH. And if the two angles in question are H and K, then side HK is stuck between both angle H and K. Now, what about my angles? Well, let's take a look. If we are given 2 sides, what angle is caught in between them? Well, that's going to be, let's see, L and L. So LN, LM, those are both segments off of L, angle L. Therefore, angle L is the angle in question. And then angle N and angle N because it's NM and LN. So those are, that would give me angle N as the included angle. Give a reason to justify each statement. Well, the third angle theorem states that if two pairs of angles in triangles are congruent, then the third pairs in these 2 triangles are also congruent. Mathematically, they have to be. And PR congruent to PR, well, that is the reflexive property. And or you could even say the shared side. If they're a shared side, then those sides have to be congruent. But it's also the reflexive property of congruence. All right, and what are the congruence criterion up until this point? Well, just prior, I talked about side, 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 and side angle side, so that's all we know as of yet. So that is the those are the theorems that we know about at the moment. So what are we learning today? We are learning angle, side, angle, and angle, angle, side. So with this, if we have angle, side, angle, so let's do angle, side, angle. Angle, side, angle. So let's say we have a side that is, I don't know, an angle that is 32 degrees and 48 degrees, and a side that is 26 inches long, or whatever. Let's just say 26 units. Then I have another triangle that has 32 degrees, 48 degrees, and a 26 that's included with the side, 26 length. Then we know that these are congruent. Change the color of this to demonstrate that they are different than the angles. And then in angle, angle, side, you have to be very careful. So this involves an inclusion. So this is included side. It's stuck between the angles. What we have to be cautious of is angle, angle, side. Because angle, angle, side, really, if you think about it as angle, when we go around our triangle, we really go angle, side, angle, side, angle, side, angle, side, like that. But here's what we're doing. We're going angle, angle, side. We're skipping a side. So when you look at it, we're really going from a side and an angle. We're skipping a side and we're ending up at another angle. So these 2 items were both included between the farthest angle and side, but this side is ignored. It's very weird, but I'll show you a bunch of examples. So again, when you're looking at an angle, so an angle, a side, you're going to skip that side, and then you're going to go look at your next angle with this side here. So it's kind of weird. This side gets skipped. But it is what it is. But it works. It works. There's not an example where it doesn't work. Okay? So again, you're skipping this side right there. Kind of weird, but the angle's kind of included, but the side isn't included, so it's really not included. So I'm not going to use the word included for this. You just have to be really careful when we get to these. Okay? So in lesson 2, you learned about the side angle side, right? And here, now we look at angle side angle. So take a look. There's your included side. So here's your angles. And then what's caught between them is the side. So the side is stuck between both angles. And that's it. So just remember that side's included. And then the angle side one. Oh, wait. Yep. So here's our 2 theorems for today. There's your angle side angle. And then, you know what? I will bring this down over here. No, I'll leave it up there. And the angle side, again, it's kind of like you're going around your triangle. Angle, here's your angle, side. But you're just skipping that side right there for angle, side. There we go. I don't like this. This always doesn't want to do it the first time. There you go. So you're skipping that side. So it goes angle, side. And that's it. So if 2 angles and a non-included side of one of the triangles is congruent to 2 angles and the corresponding non-included side of another triangle, then the triangles are congruent. So let's do some actual examples. This first one, which one is congruent by side angle side? They give you 3 triangles. So let's take a look. Oh wait, it says using angle side angle. I'm sorry. So using angle side angle, which is cat congruent to? So triangle CAT, here's our angle, our side, and our angle. So let's look at these. Here's your angle, here's your side, and here's your angle. And then here's your angle, your side, and your angle. Look at that. That doesn't match up. So this one is by angle side angle in order. This is angle side angle in order. And this is angle side. You notice, see, here's your skipped side. This is a skipped one. So it goes angle side. So these are both appropriate, but it asked us by angle side angle which 2 are congruent. And so we have to say that CAT, so triangle CAT, notice the order I went in. I went from C to A down to T. So I kind of started at the 1 tick mark, went to the 2 tick marks, went to the 0. So I need to follow that pattern. 1, 2, 0. And so that's going to give me, so triangle, this isn't coming along well. Triangle CAT is congruent to triangle 1, so that's going to be G, D, O. So again, 1 tick mark, down your side, towards your angle, and then down the side with nothing. And that's the order that matters. So triangle, why am I having so much trouble? GDO. That looks a little bit better. And so do I see GDO anywhere? Oh, I surely do as one of my options. All right, can you conclude that that triangle INF is congruent to either of the two triangles? Explain. So the answer to this one is no. This is this is not, this triangle is not congruent by angle side angle. However, it does have the ability to be congruent by angle side if another triangle had those properties. Alrighty. So this is a homework for exercise notes 4.3. Well, this is still part of our lesson. I'm just going to do this one quickly. So name two triangles that are congruent by ASA. So let's take a look. This one looks like it is by ASA. This one looks like it is by ASA right over here on the right-hand side. But it does look like this one is by AAS in the middle, because it looks like we skip over that side and the side is not included, while these sides are included between WV and P and R. So we're going to name the two triangles that are congruent. And so this is going to be triangle PQR, congruent to triangle, and I'm going to go in order let me erase that. Let me do triangle PRQ. Again, it doesn't matter, but PRQ. I figured I would go start at the 1 tick mark of the angle, go to the 2, go to 0. So 1, 2, 0. So I'll go 1, 2, 0, which is VWX. So congruent to triangle VWX. The next one, angle side angle, looks like I have angle side angle. Let me change the color. Angle side angle. Looks like I have angle side angle. Looks like I have angle. What do I have here? Whoops, my apologies. I don't have angle side angle. I have side angle side. I have angle side angle, and then I have angle side angle for this one as well. Even though there's an extra side there, that's okay. I do have angle side angle. So let's look at our tick marks. 1 tick mark, that's your angles. Another tick mark, that's your side, followed by another angle right here. And so it is in the same order, and it also has an included side. So that works. Even though they added more, that's okay. So I'm going to say triangle A, B, C. So I'm going to go 1, 0, 2, and then I'll go 1, 0, 2. So is congruent to triangle EDF. All right. Okay. Answer each question without drawing the triangle. That's okay. I don't need it. Which side is included between angle R and angle S? Well, if angle R and angle S are the angles, then the side between them have to be RS. So it is side RS. Which angles are included between which angles include side NO? So it is angle N and it's angle O. And that's it for that one. Okay. Let me change the color for this one right here. All right. Write a congruent statement for each pair of triangles. Name the postulate or theorem that justifies your statement. So here we can mark this piece right there as being congruent. So write a congruent statement for each pair of triangles. Name the postulate or theorem. So this is by the angle side angle postulate. And it is triangle MOP is congruent to triangle MON. So I did MOP, I went 1, 2, 0. Then I have to go 1, 2, 0 in the other direction. This next one looks like we have a shared side here. There's a lot going on. We got angles, we got congruent angles for U and R. I also have parallel lines cut by a transversal. You know what I'll do? I'll just throw in some tick marks here and here because those are my alternate interior angles. So we have triangle first off, it's by angle side postulate or theorem. It's probably the theorem, but it doesn't matter. Angle side theorem. And it's going to be triangle UST is congruent to triangle RTS. I'm going in the same order. And this one I think I did earlier in the notes, but I'll just go over it again. This is by the angle side theorem again, because angle side, you're skipping this side right here. So angle side, there is no inclusion. And it's triangle ZVY and WVY. And so that's your triangle congruent statement for that one. All right. For the triangles shown, D is congruent to T, E is congruent to U, and EO is congruent to UX. Which of the following statements is true? So D is congruent to T. We have U and E. And we have EO is congruent to UX. So right away, I'm taking a look at this. I'm looking like we skip this side here, right? So it's two angles and a side. So the question is it angle side angle or is it angle side? And it can't be angle side angle because we're skipping, the side's not included. So with two angles with a non-included side, it has to be angle side or AAS. So we're skipping that. So it looks like it's going to be by angle side, which eliminates this option and this option. So now we just have to go in the right order. So UTX and DEO. UTX, so that's 210. EDO, UTX, EDO, UTX, EDO. No, that's DEO, so that's not an option. But let's go back and let's make sure TUX, let's make sure it goes in the right order. TUX goes 1, 2, 0. So DEO 1, 2, 0. DEO TUX, it goes 1, 2, 0. I like this one. There we go. It's going to be that one right there. Okay. For the tick marks, TUX, it goes 1, 2, 0. So you could even mark that down. You don't need to. 1, 2, 0. This one goes 1, 2, 0. So it all ends up working out. Okay? And that's it for that. So we'll do this in class, the practice 4.3, but I did the notes part of section 4.3. Good luck. Hello, students. Welcome to Unit 4 Notes, section 4.6. At this time, you can try the warm-up on your own. Pause the video. I'm going to begin it. So I started doing the first part of it. Tell whether the abbreviation identifies a congruent statement. The answer for side, side, side is yes. The answer for side, angle, side is yes. The answer for SSA is definitely a no. We don't have a side, side, angle theorem or postulate. Here, angle, side, angle is a yes. Angle, angle, side is a yes, and angle, angle, angle is a no. And there's a couple of reasons why angle, angle, angle is a no, and why side, 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 angle is a no. Think about in a side, side angle, if we were to have, well, first off, let's do the angle, angle, angle one. So here's a triangle. Whoops. Here's a triangle. Here's another triangle. I'm going to enlarge, and I'm going to demonstrate that, yes, the angles might be congruent, but that does not make the sides congruent. Therefore, that's the reason why angle, angle, angle doesn't work. Okay? And for side, side angle, let's take a look at side, side angle and the reason why it might not work. So here's a side, and an angle. Let me just do this right here. So what I'm going to do is I'm going to take this and I'm going to copy it right here, and I'm going to copy this right here. So in this case, yeah, this side, side angle would be appropriate. So let's do side, side, and angle. So yes, this does look like it works. However, this is not what I wanted. I'm sorry. Let me do this side, side angle. Let me do it this way. The way I drew it was a little bit off. There we go, side, side angle. So here you have side, side angle, side, side angle. It looks like it works. You go astray. Hey, that's enough information. But watch this. Watch what we have the ability of doing. What if instead of it being set up that way, what if this segment here was equivalent, but it went this way instead? So let me erase this, and let me put that in. Wouldn't you agree that this side is the same length as this side, and this side is the same length as this side, and this angle is congruent to this angle? Yet you can tell I have two different triangles. So we have to be careful. This angle being pinned down is the wrong angle to be pinned. We need this angle pinned, because this could be an obtuse angle or an acute angle and still keep the side lengths exactly the way they are. So that's why side, side angle does not work, and why angle, angle, angle also does not work. However, there's a special case. A special case. Oh, let me use a different color. We've used almost everything except for this one. Special case. If we have a right angle. Because we actually would eliminate this option of this. This is called a swing side. Like a side, it has the ability of swinging and being in either location. If we do have a right angle right here, or if we have a right angle, what we do is we pin, if this one were to be a right angle, we actually force it to be congruent. So we won't have an option there. It will actually be congruent. But that's a special case, and we're going to talk about that today. Okay? That's what the lesson's about today, is that special case where side-side angle does work out. We don't call it side-side angle. We'll get to it. So let's take a look at this one. Here we have We have a shared side. So can we conclude that the two triangles are congruent? Yes, by side, angle, side. Okay, here's your side, angle, side. Here's your side, angle, side. This one is, we have vertical angles right here, and this is yes by side, angle, side as well. Okay. The lesson today is on the congruence in right triangles. So if we have a right triangle that has a leg and a hypotenuse, right? Here's your hypotenuse, it's always opposite the right angle. So in a right triangle, the side opposite the right angle is the longest side, and we call it the hypotenuse. The other two sides are called legs. The right triangle provides a special case for which there is a side-side angle congruence rule. It occurs when the hypotenuse are congruent and one pair of the legs, either pair, it doesn't matter, it could be this one, could be that one, are congruent. So if a hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So here's what you need to ask yourself. Is it a right triangle? Do we have congruent legs? And do we have congruent hypotenuses? Okay? And these are actually, let me rewrite it. Okay, so two triangles. Yep. Do we have two right triangles? One pair of congruent legs, of congruent hypotenuses, and one pair of congruent legs. That's our question. Do we have those three things? Okay, so I just said myself, legs, hypotenuse, right angle. And if so, then we have the theorem. So, which two triangles are congruent by HL? Yes. And that's it. So let me draw an example. So in this case, I'm going to draw this one right here. Okay, I'm just going to copy this over. I'm going to throw a right angle right here. And I'm going to say, okay, we have a pair of legs, a pair of hypotenuses. Look at side, side, angle, side, side, angle. So that will work out. And the reason, again, why it works is because this is a right angle. What we did was we pinned this down to be a right angle, and we don't have an option. One of those is a right angle. It doesn't really matter. We forced it to be a right angle, therefore it will have to be congruent. Okay? So we're going to do some of these practice problems in our notes, and then in class we will do this practice worksheet. So I'm just going to do a couple examples. So it says, which two triangles are congruent by HL theorem? Write a correct congruent statement for the pair. So let me put in my tick marks. I got 3, and I got 3, and I got 3. I got 5. I got 5. I got 5. And I got right angle, right angle, right angle. But let me take a look. It looks here like the hypotenuse and the leg is given. Here it looks like a hypotenuse and a leg is given. Here it looks like a leg and a leg is given. So this is not the option I can go with. This is by side angle side. These are by HL. So I'm going to say that triangle LMN is congruent to triangle, and I got to go in the same order. Look at what I did. I went LMN. I went down the short side and the side with no value. So I have to go down the short side and the side with no value. So triangle LMN is congruent to triangle OQP. And we are done. That's it. So, well, I'm going to say yes by HL. And that is the statement for how they're congruent. Okay, what additional information do you need to prove that triangle is congruent by HL? So what do we need? Well, it looks like we have our what could be a hypotenuse. Looks like we have what could be a hypotenuse. Looks like what we could have is a leg. So I have my hypotenuses. I have my legs, my pair of legs. Yep. Do I have my right triangles? And the answer to that is no. So I would need that information. So I would need to know, we would need to know that angle T and angle Q are right angles. And that's what we would need to know. That's not what we're given. So we need to know. And we're done. Okay? Here in this one, we have, this is a shared side. Looks like the hypotenuse. So do I have my hypotenuse? Yep, my two hypotenuse in each triangle. Do I have my legs? My legs, I don't see them. And so and then do we have my right triangles? And the answer is yes. So what I need to know, we need to know a pair of legs. So it could be, we need to know that XV is congruent to TV, or that XR is congruent to TR. I can either one of these. I need to know this part and this part, or this part and this part. Either one works. We just need to know that they're congruent. Whoa. All right. Next one. In exercise 10 and 11, for what values of x and y are the triangles congruent by the HL theorem? Well, what that would mean is that I would need to set them equal. So x would have to equal y plus 1, and x plus 3 would have to equal 3y. And this is going to be, as you can see, for both of these, you have, x plus 3 would have to equal 3y. This isn't that pretty. This is a system of equations, right? So you have this system of equations, and I'm just gonna be consistent with what I'm setting equal, because those are your hypotenuses, and those are your legs. You're gonna have to solve this. It's a multivariable, right? So what I'm gonna do is I'm gonna take y plus 1, and I'm gonna put it in for wherever I see x. X is equal to y plus 1. So this will help me with my system of equations. I'm using substitution to solve for this, because I'm taking, wherever I see an x, I'm putting in y plus 1. So I get y plus 1 plus 3. So I get y plus 4 equals 3y. So I'm going to take away a y. And I get 4 equals 2y divided by 2. 2 is equivalent to y. Okay? And now that 2 is equivalent to y, I now can put 2 back in up here. So let me do a different color. I can put 2 into either equation. Oh, you know what? I'm going to put into this first one. So x equals y plus 1. So x equals 2 plus 1. So x equals 3. And I now get both values. So x would have to be equal to 3. So let's check our work. 3 plus 3 is 6. And when y is 2, we get 2 times 3 is 6. So 6 and 6. And then 3 here, and 2 plus 1 is also 3. So everything works out well. That's exactly what we needed. Okay? This next one for number 11, I'm going to do the same thing. I'm going to use different colors. Try to. Y plus y minus x is equal to x plus 5. So y minus x equals x plus 5. And then I'm going to do, let's see, I'll do light purple. I'll do 3y plus x equals y plus 5. And you know what? I don't really like either of these. Let me do some math to to move things around here. So I'll add x to both sides just to move them over. So y equals 2x plus 5. And then this one, I'm going to just move y over. I'm just trying to condense my variables a little bit. So 2y plus x equals 5. Okay, you know what? I'll take this and put it in for wherever I see a y. So 2 times 2x plus 5 plus x equals 5. So I'll get 4x plus 10. I have to use the distributive property. Don't forget the distributive property. Plus x equals 5. So 5x plus 10. I'm going to combine like terms. I'll take 10 away from both sides. I get 5x equals negative 5. Divide both sides by 5. X equals negative 1. Feel free to rewind the video and watch it a couple times. I'm just trying to save time. If you can follow it, great. If not, you can replay it. So x is equal to negative 1. Now let's take our x and let's put it back into our equation. This one works. So y equals 2x plus 5. Y equals 2 times negative 1 plus 5. So y equals negative 2 plus 5. So y equals 3. And we're going to check our work. We're going to make sure that x is negative 1. It's kind of weird to have a negative, but that's okay. And y equals 3. So if x was negative 1 and y is 3, we would get 3 minus negative 1. So 3 plus 1 is 4. So that works. And then negative 1 plus 5 is 4. So that works. Now these two, if y is, what would I say, 3? So 5 plus 3 is 8. And then we get 3 times 3 is 9, plus negative 1 is also 8. So this one works just as well. Okay, so we're going to do the rest of these problems in class, and you'll get plenty of practice with your IXL as well. Okay, good luck.